Hey everyone, and welcome. Today, we're going to break down a huge programming idea that, believe it or not, you use every single day: abstraction. We're going to see how the simple act of using your TV remote connects directly to building massive, stable applications in Python. Let's dive right in.
Now seriously, think about it for a second. You pick up your remote, you press a button, you've done it a million times, but what's actually going on behind the scenes to make the magic happen?
For you, the user, it's super simple, right? You press on, the TV turns on, you hit volume up, the sound gets louder, it's direct, it's predictable, you know exactly what to expect from each button press.
But here's the most important part. Think about what you don't need to know. You don't have to understand infrared signals or circuit boards or how the TV's internal hardware decodes those signals. All of that insane complexity is totally hidden from you. You just care about what it does, not how it does it.
And that right there, that's it. That is abstraction. It's this powerful idea of hiding all the messy, complicated reality behind a super simple interface. You've been an expert at using it your whole life, and you probably never even knew it had a name.
So, if we had to put a textbook definition on it, this is what it would be. Abstraction is all about hiding the complex implementation details and only showing the user the essential features they need to interact with. It lets us as programmers call a simple method without having a clue about the hundreds of lines of gnarly code that might be running underneath.
Okay, so why should you, as a developer, care about this? Well, because abstraction isn't just some neat theory, it's the absolute bedrock of writing clean, stable, and maintainable code. Let's take a look at why.
Imagine trying to drive a car, where instead of a steering wheel and pedals, you had to directly manage the fuel injectors and the spark plugs. It would be an absolute nightmare, right? Well, code without abstraction is kind of like that, a tangled, exposed engine, where one tiny wrong move could break the entire system. With abstraction, we get a clean, simple dashboard. It makes our systems robust, safe, and way easier to use.
And this is a really big deal. This isn't just for small scripts. Abstraction is the secret sauce that lets developers build massive, complex applications. It's how you build software that can actually be maintained and scaled over time without just collapsing under its own weight.
Now let's quickly clear up something that trips up a lot of people: the difference between abstraction and encapsulation. Think of it this way. Encapsulation is like building a strongbox. It bundles data and the methods that use it together to keep the data safe. Abstraction is about putting a simple, clearly labeled button on the outside of that strongbox. So encapsulation is about protecting the data, and abstraction is about simplifying the interface.
All right, so we got the what and the why. But how do we actually do this stuff in Python? Well, let's get into the toolkit Python gives us to make this happen. Python's main tool for abstraction is a built-in module called ABC, which stands for, you guessed it, Abstract Base Classes. And from this module, we really only need two things: ABC, which is a special class that we'll use to create our blueprint, and a decorator called @AbstractMethod, which is like a little flag we put on methods to say, hey, anyone who uses this blueprint must provide their own version of this. So let's create a blueprint. We'll make a vehicle class, and you can see it inherits from ABC. Then we define a method called move, and we stick that @AbstractMethod decorator right on top. Inside, we just put pass. We're not saying how a vehicle moves, we're just making a rule. We're saying any class that wants to be considered a vehicle absolutely has to have a move method. Our blueprint is intentionally incomplete. And you might be looking at that and thinking, okay, so what's stopping me from just using this vehicle class directly? If it's a class, why can't I just make an object out of it? And here's the answer. Python itself will literally stop you. If you try to create a vehicle object directly from that blueprint, Python will raise a type error. And this isn't a bug, it's the whole point, it's a feature. Python is enforcing the rule we created. It's saying, nope, you can't build this thing because it's not finished yet. You promised me a move method and you haven't delivered.
So if we can't use the blueprint directly, how do we actually make it useful? Well, this is where the fun really begins. We're going to bring that blueprint to life by creating what are called concrete classes.
Check this out. Here's our first concrete class, a car. We create a car class that inherits from our vehicle blueprint. And then, this is the critical part, we provide an actual working move method. We've now fulfilled the contract. We've followed the rules of the blueprint, and so our car class is now a complete, real, usable object.
And boom, we are right back to the TV remote. The person using our car object has no idea what's going on inside that move method.
They don't need to know about engines or transmissions. All that complexity is hidden away. All they need to know is that one simple command, c.move.
But here's where this approach gets really powerful. We can create another class, let's say a bike. It also inherits from vehicle, and it also has to provide a move method to follow the rules. But its internal logic, how it actually moves by pedaling, is completely different from a car's engine. And the beautiful thing is, our blueprint doesn't care how it moves, only that it can. Now for the grand finale. Because both car and bike follow the same vehicle blueprint, we can treat them exactly the same from the outside. Look at this. We can put them in the same list, loop through that list, and call .move on every single one. And what happens? The car moves like a car, and the bike moves like a bike. Same interface, totally different behaviors. This idea is what makes our code incredibly flexible and so much easier to build upon.
All right, let's tie this all together. We're going to look at a big real-world example, and then I'll give you a quick checklist to take with you.
Think about any time you've bought something online. Your interaction is as simple as it gets. You click a button that says pay. But behind that one simple action, an enormous amount of complexity is firing off. The system has to validate your card, talk to the bank, run security checks, confirm the transaction. Abstraction is what makes that entire ridiculously complex process look like a single, simple step to you.
Now, as you start playing with this, here are a few classic tripwires to watch out for. First, remember you can't make an object directly from an abstract class. It's just a blueprint. Second, make sure your concrete classes implement all of the abstract methods from the blueprint. And finally, keep the difference straight. Abstraction hides the how, while encapsulation protects the what.
So let's nail this down. Here's your abstraction checklist. At its core, it's about hiding complexity. In Python, you use abstract base classes, or ABCs, to create blueprints. These blueprints force other classes to follow a set of rules. And the result? A much better code structure that lets you build big, scalable systems.
So, we've gone all the way from a simple TV remote to the architectural backbone of massive software. But the principle is exactly the same. Hide the messy details and provide a clean, simple interface. So the question I want to leave you with is this. Now that you understand how to build the blueprint, what complex system in your own code are you going to simplify next?